So welcome to Autodesk HSM CAM, that is computer aided manufacturing. You are using, when you say computer aided manufacturing, it means you are using a computer, because a computer has memory, has processing, has inputs, outputs. So it helps you to process the writing of a program, because in CNC we call it computer part program. A part program, you are writing a program to machine a single part. You can call it a component or a part. The language is part program, so it's computer numerical control. So you're using a computer to help us in automating manufacturing. And because our manufacturing category here is CNC, which means doing subtractive machining. So we want to do a simple programming. We can do programming using manual way of programming if you're using your programming simple parts. But if you're programming complex parts, you can go to computer aided part programming using softwares like Solid CAM, Inventor CAM, Master CAM, Edge CAM, maybe Sprut CAM. There are so many softwares you can use for to help you in automating programming. I normally use Master CAM, Solid CAM, HSM, Inventor CAM, but now today I'm showing you how to program on what you call the HSM Works. This is a simple part which has I will be doing facing, be doing chamfering, and also step turning. 3 operations for facing, step turning, that is rough step turning, and then finishing. With the tool for roughing is DNMG 15040804. Here is the thickness, and then 08 is the radius. Here the same for facing, roughing, then finishing. I'm using DNMG 160404. So for quick operations, I've also already done the setup for facing, for rough turning, and profile finishing. So here I want to maybe let me generate a sheet operation, then I'll show you sheet operation, how it looks like. So this is the part, the stock. The final part has the maximum diameter of 26 and the maximum length of 70. So I'll use a stock of 30, because we're doing subtractive machining. I don't want to waste time in my programming or my machining. So I'll use a material which is close to that, although maybe you may not find the actual stock like 30. You may find maybe that 3, that is 1.5 inch, maybe 2 inch. One inch may be difficult, because already this one is 26 millimeter, because 1 inch is 25.4, so it won't fit here. You need more than 1 inch, so 1 inch diameter for you to able to produce this part of diameter 26 and the length of 70. Good. So there are 2 tools and 2 operations. If you're using other machines like Fanuc, Haas, GSK, Century Star, normally the tool when you're programming is written T2, maybe it's T202 or T2, T101, T303. But for this one, I'm using Siemens controllers, so it is 2 tools. So the first tool, the second tool is for finishing. I've only generated for finishing, which is using this is T2 D2, has an ISO angle of 35, that is V in MG. So if you go back to the original one, which has this, we have T1 D1, that is the ISO at 55 degree DNMG. Maybe let me show you the tool. This is the first tool, T1 D1, then second tool, T2 D2. Then here, let me do a simple simulation. Maybe we can see how it look like. You can see how it look like very fast. Then we go to the G code. I'll explain the G code. I'll explain the G code. So it will be doing 3 operations. Yes, it has done the roughing. It goes to yes, then finish. Good. So then let me generate a G code here. Generate a G code. I want to look at my machine is Siemens. The vendor manufacturer of my machine is Siemens. Then it is turning. I'm using for turning. I'm using which controller? I'm using 840. Yes, 840 means my turning, let's say 002 millimeters. Okay, then I can post. Let me see. Yeah, let me save the program. Let me see how it will generate the program. So this is the program. It has this G90. It is using absolute programming G94 depicted in millimeter per revolution, and then G18 using XZ line G71 meaning millimeter. The units are in millimeter. G40 it has cancelled all tool compensations. Then G92, although I can use G96, but the G92 is okay. So the speed is maximum of 6,000. Then G3 selecting the coordinate system. First of all, is doing what you call a referencing. So the first operation here is facing, that is T1, D1. So it is doing facing. Then second operation here, it will be doing rough turning. Then the third operation here, down here, it will be doing finishing. So this is for finishing. M1 is either M01. It is telling the machine that you pre-stop the spindle, then that is conditional stop of the spindle, so that it can change the tool from T1 D1 to T2 D1. I've already put my offset on same position. That's why it's telling, it's written T2 D1. I can use T2 D2 different positions. So this is the part program. Part program. G we normally call G and M code. G is preparatory, M is miscellaneous functions. So this is what we normally do in CNC machining. So this is a part program.